Okay, in this video, we're going to talk about systems of equations, okay? Linear equations. Now, up until now, our dealings with equations have all been solving linear equations of one variable. 2x plus 3 equals 9. How do you solve it? You get x all by itself. You perform various operations. And ultimately, you get a unique answer, x equals, in this case, 3, something, okay? That's a linear equation of one variable, okay? What about a linear equation of two variables? What if I did something very similar and I just said, x plus y equals 10? And this is kind of a whole new ballgame because although there was only one solution to this problem, there's an infinite number of solutions to this problem because each solution has an x and a y component. So any combination of x and y that would make this a true statement is a solution. If x is 1 and y is 9, that equals 10, right? If x is 2 and y is 8, that equals 10. I can go on forever, right? Think a little bit outside the box here. What if x is 100 and y is negative 90? That equals 10, right? What if x is negative 1,000 and y is positive 1,010? That equals 10. Okay, so I can go on forever. There's an infinite number of solutions to this problem. But infinite doesn't mean anything goes. If I say x is 4 and y is 5, well, no, that does not equal 10. So that would be no good. And in an algebra class, you would talk about these equations and then you would ultimately graph them. Remember good old graphing? There's no graphing on the exam, but x and y coordinates, and you're plotting all these points, right? Ordered pairs are always in the form of some x comma y. And you got all these little dots on the paper, and you connect the dots, and it's a line. Now, I'm not going to attempt to graph this one perfectly by any means, but it's going to be some kind of line that looks like that, okay? And we put the arrows indicating that it goes forever. This is the equation of that line, okay? And generically presented, we talked about things like slope and intercept. Again, in an algebra class, we didn't talk about them. And we had this little template called y equals mx plus b. It's all coming back to you, right? And you can graph a line that way. Very quickly graph a line. Well, that's a linear equation of two variables. It has an infinite number of solutions. What a system of equations is. A system of equations is where we have two of these equations and each one has two variables. Okay? Graphically, and again, we're not graphing, but I just want to show you what we're doing. Graphically, I've got my x and my y axes here. I'm going to have some line, whatever it is, there's a line, and there's some equation that goes along with that line. Y equals mx plus b. Okay? And it goes forever. It's got all these points, all these x comma y's, right? They're all solutions to that problem. Well, now I'm going to have a second line. Okay? And it's some other y equals mx plus b. Okay? It's its own equation. And it has its own infinity of points here. Okay? The blue line with the blue equation's got all the blue points. The black line with the failing marker and the black equation and all the black points go together. Okay? Now, none of these black points work in the blue equation and none of the blue points work in the black equation. But as you can see on the board, there is one special point, and it's this point here. It's the point where those two lines cross, and it doesn't have to be right on the axes like I showed it there. It just worked out that way. It can be anywhere. But that's a very special point. We call this the solution to the system. Okay, so solving a system of equations is all about telling me where the lines cross if we graph them. Okay, but we're going to do it without graphing. We're going to look at two other techniques. Now, a couple of real quick special cases. Again, you won't see this on the exam, but just real quick. Here I've got another one. If I have one line that looks like that, and I have another line that looks like that, we call those lines parallel. They never cross. So if by solution I mean tell me where they cross and they don't cross, this has no solution. Okay, and then another extreme case. Okay, here's my first line, and here's my second line. It's right on top of the first line. Well, there, of course, every point that works in the first equation also works in the second equation. So we would describe this as having an infinite number of solutions. Okay, you won't see either of those on the exam. What you'll see is one of these, although we're not going to graph it. We're going to have two equations. They cross somewhere, and we want to identify what is the x comma y. What is the coordinate of that point? That's what we want to find. We're going to find it two ways. The first way is called the substitution method. Okay, so we're going to have two equations. Here's the first one. Y equals negative x minus 1. Here's the second one. 4x minus 3y equals 24. What we do here is we substitute information from one equation into the other. Well, the first equation tells us, hey, y equals all this stuff here, negative x minus 1. So I'm going to take all this stuff, and I'm going to put it down in the other equation anywhere that I see a y, because that's what y is. Y is negative x minus 1. So I'm going to rewrite that second equation. I'm going to be careful here. I have negative 3 times y, but y is now a bunch of stuff. It's a quantity. I'm going to open a parentheses and put all the stuff in there and then close the parentheses. Negative 3 times y equals 24. Okay, now look what just happened. Y magically disappeared. Shazam, it's gone. All I have left is x. Now it's like a quote unquote easy equation, right? 4x, we distribute, we're going to get plus 3x plus 3 equals 24. Combine like terms here, we'll get 7x plus 3 equals 24. Solve for x. Okay, now it's kind of easy. 7x equals 21. X equals 3. Okay, that's half the answer, right? I mean, a minute ago, we were solving linears. We said x equals 3, and we circled it, and we walked away. We were done. Well, now we're not done. Now we're looking for an x comma y. Again, if we were to graph where those two lines cross, where do they cross? There's an x component, there's a y component. We now have the x component. We need the y. So we go back to either equation, whichever one looks the most user-friendly, and that top one looks the most user-friendly to me. And we put in now our real value for x, and then we find y. So I'm going to put in a 3 for x. So y is going to be a negative 4. Okay, so I kind of circle these as separate answers. They're not separate, they're part of the same answer. We write it as an ordered pair, the x coordinate, comma, the y coordinate, and that's how we would show our answer, 3 comma negative 4. Okay, all good there? So that's how you would do the substitution method. Now this one was set up to lend itself very well to that method because we already had one equation that was solved for y already. So you just plug it in the other equation. That's not always going to happen. Okay, sometimes you have to make a choice on what you're going to solve for. Like, let's look at this example. Here we really have 4 choices. We can solve for this x, this y, this x, or this y. And we want to pick the easiest one. So if there's a nice, beautiful coefficient of positive 1, it's really easy. Even negative 1 is pretty easy. So we'll search for that. If you don't have that, again, with experience, you can kind of tell which ones are going to be more user-friendly than the other. You're not going to see a lot of these on the exam, so I'm not going to really harp on this decision-making process, okay? But in this case, we'll want to solve that bottom equation for x. So I'm just going to do it right here in place. So how do you solve for x? I'm going to get the 2y out of there. Add 2y to both sides. So now I've got x equals 2y minus 3. So that's one equation. That's my modified bottom equation. I'm going to substitute that now back into the top equation. You always have to substitute it back in the other equation. So that came from the bottom, so now I'm going to put it in the top. So now my top equation is 5 times x, but x can now be represented as 2y minus 3 minus 4y equals 9. Distribute, simplify, off we go here. 10y minus 15 minus 4y equal 9. That'll be a 6y minus 15 equals 9. Add 15 to both sides. Add 15 to both sides, right? 6y equals 24. And we'll get y equals 4. Again, that's only half the answer. We need to find the other half. Where do you go? Well, you can go back to either original equation, or let's go back to our modified equation because that's already solved for x. X equals 2 times y minus 3, but now I know y is 4. So 2 times 4 minus 3. 8 minus 3, so x equals 5. Okay, so our solution is going to be 5, 4. Okay, that is what we call the substitution method. Substitution method. All right, there is another way to do these types of problems. And again, depending on the problem, some ways are going to work a little more user-friendly than others. I would probably use a substitution method unless it was obvious not to use it. Okay, but real quick, let's talk about the other method. It's called the elimination method or the addition method. Okay, here's an example. X plus y equals 4. X minus y equals 6. I am literally going to add these equations together. X plus x gives me 2x. Y plus negative y, 0, right? I'll just write plus 0, but we don't have to write 0. Equals 4 plus 6 is 10. So all of a sudden my y's are gone, and I'm just looking at 2x equals 10, divide by 2, and I've already got half my answer. X equals 5. Go back and find y. Pick an equation, makes no difference which one. X is 5, I'll put it in there, which means I'm going to subtract and get y equals negative 1. So 5, negative 1 is my solution to that system of equations. Okay, now boy, didn't that look a lot easier? Well, we lucked out because all I had to do was add the two equations and y magically disappeared. If y doesn't magically disappear when I add the two equations, it's no good. Okay, I have to do some manipulations first. Let's look at this one. Okay, here if I simply add the equations together, I'm going to have still an xy equation equals a number. And now I'm going to be up the creek because I'm going to have a single equation and two unknowns, and that's no good. So before I can add them, I have to manipulate one or sometimes both of the equations, okay? The goal being I want either x or y to disappear. So I gotta think and I gotta ask myself a question. Well, I've got a negative 8y here. If this were a positive 8y, then positive 8y plus negative 8y goes to 0. So I'm going to manipulate the top equation by the process of multiplication, and I'm going to multiply the top equation by 4. Okay? What happens when I do that? I get 12x plus 8y, so now I'm writing the top equation down here on the bottom, okay, but it's the top equation. 48 times 4 is what? 190, 2, right? 192. Okay, I always gotta stop and think sometimes about the easy stuff. You know, 32 carrying the 3, yeah, 192. All right, I'm convinced now. I'm happy. All right, so now what happens when I add? Well, now the 9x and the 9x and the 12x gives me 21x. The negative 8y and the positive 8y, that's gone. And I got to do 192 now minus 24. You know, I hate doing, again, it's real easy, of course, right? But sometimes these little on the fly arithmetic problems, especially, you know, come on now. I'm really botching it. I don't have my official calculator either. And now I can't even unlock my phone. The pressure's on. What is that going to be? Let's just get it right. 168. Okay. Divide by 21, which I can also conveniently do here. And we're going to get an 8. Okay. X equals 8. Half our answer. We need to go back and find the other half. Pick either equation, makes no difference. I'll just grab the top one. Okay, so that's going to be 24 plus 2y equals 48. Subtract 24. 2y equals 24. So y is going to be 12. Okay, so 8 comma 12 is the ordered pair that I'm looking for, is the solution to this system. Okay, I think you'll have one, maybe two of these problems. Now, if it just happens to be that case where the lines were either parallel, no solution, or infinite solutions, what would happen is we'd perform these operations, and all of a sudden we would either get a true statement or a false statement. In other words, the x's and y's would all disappear. Okay, I would work my magic. The x's and y's would all disappear when I add that left side of the equation. I'd be left with nothing but a 0 on the left side. Equals something, could be anything. Let's just say -8. I could be left with 0 equals -8. Well, that's obviously a false statement, 0 equals -8. So if that happens, I'm going to say no solution. Okay. If I'm left with a true statement, could be 0 equals 0, could be anything. Could be -8 equals -8. If all the x's and y's drop away, but I'm left with a true statement, aha, then I say infinite solutions. Okay. I doubt you'll see either one of those on the exam. You're going to see a good old traditional problem looking for that ordered pair when the lines cross. Okay. You might be asked which one of these answers is the correct one. Well, you just test it out. I mean, if we were given this last problem, if we were given this, and we were just said, here's your choices: 3, 4, 6, 8, and 5, -1. Which one of those works, right? Well, you just try it out. You just say, well, I can squeeze it in here. You just try it out. You say, okay, I'll grab 3, 4, and I'll try it up here. If x is 3 and y is 4, my first equation says 3 plus 4 has to equal 4. I can immediately say that's no good because it fails. All right, let's try the 6 and the 8. 6 plus 8 has to equal 4. Okay, well, that's no good. Okay, I made these two up, right? It's no good. Well, then I try my third possibility. 5 plus -1 has to equal 4, and it does, right? So, okay, so far so good. But the proposed solution has to work in both equations. So now I got to go down here and try it down here. 5 minus -1 has to equal 6. Otherwise, there's trouble. And minus negative is plus positive, so it does equal 6. Right, so you'll be given a multiple choice. You'll be given a bunch of choices, and you just have to try them and see which one works. Or you can go ahead and solve it yourself and see what answer you get. But again, on the exam, it's all about time. So it might be quicker just to test the answers. Okay, but that is how we can do a system of linear equations.